P0141 on this RAM is an O2 sensor 1/2 heater performance fault. In plain language, the PCM may be commanding the oxygen sensor heater and not seeing the heater behave the way it expects. The driver may only notice the MIL, but this can affect how quickly the sensor is ready for closed-loop fuel control. The broad areas are the heater control side, the heater ground side, the sensor heater itself, connector or terminal problems, and less often, the PCM side of the circuit. Before getting deep into the test, start with the basic system checks and make sure the complaint and code information make sense. Treat the enable criteria as monitor gates, not as parts to replace. This monitor runs with the engine running battery voltage between 11.0 and 15.75 volts, no ambient air temperature sensor fault set, and one of the temperature or heater gates satisfied. Those gates are: engine coolant temperature at startup is above 7 degrees C 44, 6 degrees F. Ambient temperature is above 7 degrees C 44, 6 degrees F. The difference between engine coolant temperature and ambient temperature is greater than 9 degrees C 16, 2 degrees F at engine start, or the O2 sensor heater temperature is greater than 401 degrees C 753, 8 degrees F for more than 20.0 seconds. The fault logic is command versus response. The PCM sees the actual O2 sensor heater resistance or temperature not matching the target, while the O2 sensor heater duty cycle is above 89.8% for 90.0 seconds. First, check whether the condition is active. Turn the ignition off and wait a minimum of 8 minutes so the sensor can cool down. At that point, the sensor voltage should stabilize between 2.47 and 2.52 volts. Turn the ignition on, use the scan tool to actuate the oxygen sensor 1/2 heater control, and monitor O2 sensor 1/2 voltage for at least 2 minutes. If the voltage stays above approximately 4.5 volts, continue with the next step. If it does not stay above approximately 4.5 volts, move into intermittent condition checks instead of forcing the rest of the path. Next, read and record the codes with the scan tool. If other O2 sensor heater circuit faults are active or pending, handle the applicable diagnostic path for those first. If no other O2 sensor heater circuit faults are active or pending, keep going on P0141. Now check the O2 sensor 1/2 heater element resistance. Turn the ignition off and give the heater a few minutes to cool down from the scan tool heater test. Disconnect the O2 sensor 1/2 harness connector and measure resistance across the sensor on the component side, between the O2 heater control terminal and the heater ground terminal. If possible, make the measurement at approximately 20 degrees C, 68 degrees F, because heater resistance changes with temperature. The reference ranges are 3.14.2 ohms at 0 degrees C 32 degrees F, 3.34.4 ohms at 20 degrees C 68 degrees F, and 3.85.5.1 ohms at 100 degrees C 212 degrees F. The maximum allowable resistance would be 12.5 ohms at 1000 degrees C. If the resistance is within the acceptable range, move on. If it is not, verify good pentaterminal contact at the sensor and control module connectors. If no connector problem is found, replace the O2 sensor, then verify the repair and confirm the code stays gone. If the sensor heater resistance checks out, load test the O2 sensor 1/2 heater control circuit. Turn the ignition off, disconnect the O2 sensor harness connector, and disconnect the PCM harness connector so the driver circuit is isolated. Connect the positive lead of the load test tool to the positive side of the battery. Backprobe the driver circuit at one harness connector with the negative lead of the load tool. Then use an approved backprobe tool and a fused jumper wire to connect the driver circuit to the negative side of the battery, or a known good ground at the other harness connector. The load test bulb should be illuminated and bright, and it should compare closely to a direct battery connection. To be certain, Perform a voltage drop test across the 3156 bulb of the load test tool. A 12-volt test light can be substituted only if it draws enough current to load the circuit. Many high-impedance test lights draw less than 0.1 amps, and that is not reliable for this test. The tool should draw more than approximately 0.75 amps. If the bulb is bright, continue. If it is not bright, repair the driver circuit for an open or high resistance, then verify the repair and confirm the code stays gone. Next, load test the O2 sensor ground circuit. Disconnect the O2 sensor harness connector so you can access the ground circuit. Connect the positive lead of the load test tool to the positive side of the battery, and connect the negative lead to the ground circuit at the O2 sensor harness connector. Again, the bulb should be illuminated and bright, and you should compare it to a direct battery connection. Confirm it with a voltage drop test across the 3156 bulb if needed. The same test light caution applies here. A 12-volt test light is acceptable only if it loads the circuit properly. A high-impedance light that draws less than 0.1 amps is not enough. The load should be more than approximately 0.75 amps. If the bulb is bright, go to the connector checks. If it is not bright, repair the ground circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. If the sensor, control circuit, and ground circuit all pass, check the related harness connections. Disconnect all PCM harness connectors, any related inline connectors if equipped, and the related component connectors. Inspect the connector installation, connector locks, corrosion, water intrusion, weather seals if equipped, bent terminals, heat damage from a poor connection, push-back terminals, spread terminals, and terminal tension. Repair any conditions found. Then reconnect the PCM connectors, inline connectors if equipped, and component connectors, making sure every connector is fully seated and every lock is engaged. Erase the codes. Test drive or operate the vehicle under the monitored and set conditions, and read the codes again. If P0141 returns after all of that, replace and program the PCM using the correct programming process. Then verify the repair and confirm the code stays gone. If the code does not return, the wiring or poor connection problem has been repaired, and you still finish by verifying the repair. The takeaway is simple. Prove the heater fault is active. Check for related heater circuit faults, measure the sensor heater, load test both the control and ground sides, and only then move into connector correction or PCM action. For more diagnostic training, visit stepdiagnostics.com.